Welcome back from the ad break, and let's continue with more questions. So now we are going to be doing those application questions, and here's the first one. Calculate the intercepts of this linear graph. Now the question asks for intercepts. So we know that in a linear graph, we have x-intercepts, and we also have our y-intercepts. So when a question asks for intercepts, we are supposed to now calculate both the x-intercept and the y-intercept. So let's look at how we are going to calculate that. Let us start with that x-intercept. Now remember, what do we know about this x-intercept? We know that y is equals to 0. So let's use this knowledge to find the x-intercepts for this linear graph. So the linear graph is y is equals to 3x minus 9. Now we know that y is equals to 0. So in the place of y, we are going to substitute that with 0. That means we are left with 3x minus 9. So now we are going to use the additive inverse of a negative 9 so that we can make sure that we solve for x. So that is a plus 9, and we are going to apply this on both sides of the equation so that our equation is balanced. So on this side, we are left with 3x, and 0 plus 9 on the other side is equals to 9. Now we are going to apply the multiplicative inverse of 3, which is 1/3, and that is the same as dividing by a 3. So we are going to be left with x on the one side, and 9 divided by 3, or 9/3, is equals to 3. And that is the y-intercept for this graph. What about that is the x-intercept for this linear graph. What about the y-intercept? Of course, we know that the y-intercept we can see from our equation, which is negative 9. But remember, you can calculate the y-intercept as well. So how do we calculate the y-intercept? We know that x is equals to 0. So you can either take it from our equation if the equation is in standard form, or we can calculate it. And now taking it from y is equals to 3x minus 9, we are going to substitute 0 in the place of x, since we know that x is equals to 0. And of course, 3 multiplied by 0 is 0. We are only left with a negative 9. And that is the value of our y-intercept. So we have calculated the intercept of that linear graph. Let's move on to our next question. So our next question, we have been given a line with many points on it. We have point A, B, C, D, and E. And we are expected to calculate the gradient of this line. Now remember, when we are calculating the gradient, we only need the vertical change and the horizontal change between 2 points only. But since as well we have multi-points on this line, they are collinear, remember, on the same line. But since as well we have all these all these points on the same line, we can choose any 2, and the gradient will come out the same. And just to show you that, we will calculate the gradient twice using 2 different points. Let's start with point C and point A. So remember, the gradient is the vertical change divided by the horizontal change. So if we start with point C, that will be 0 minus 5. For the vertical change, the y values. And because we started with C for the vertical change, it means we need to start with point C for the horizontal change as well. So we are going to have a negative 2. And this is going to now subtract a 3. So negative 2 minus a 3. Now what is 0 minus 5? That is a negative 5. And what is a negative 2 minus a 3? That will give us a negative 5. So what is negative 5 divided by negative 5? If you are thinking of 1, then you are absolutely correct. This means that the gradient of that line is 1. But what if I decided to choose a different pair of points? Now, as stated before, because the lines are collinear, then the gradient will be the same between any 2 points. Any 2 points that you take on that line are going to produce the same gradient. Let's take a different set of points. Perhaps let's take point E and point B. So we are going to take E and B. Let's start with the vertical change. Now, the vertical change, that is our 3 minus our -3. And that is going to be divided by our horizontal change, which is going to be our 1. And remember, we start with point B because when we were working with the vertical change, we started with point B. So when we move over to the horizontal change, we still work with point B. So that is 1 minus a -5. So this is the gradient. What is 3 minus a -3? That is a +6. And what is 1 minus a -5? That is again a +6. Now you're looking at the 2 gradients and you might think they are not the same, but really they are, because what is 6 divided by 6? Yes, the answer is a 1. So we can see there that our gradient is a 1. So even though we used 2 different points, because those 2 points are on the same line, then that means that they will produce the same gradient. Let's move on to our next question. Our next question here, we have been given a line PQ, and we are supposed to find the equation of PQ. So let's go ahead and find the equation. Do you remember the 2 things that are needed to find an equation of a line? Yes, we need the gradient of this line, and we need the y-intercept of this line. So let's calculate the gradient of this line. When we have a gradient, or when we calculate a gradient, remember we are working with the vertical change divided by the horizontal change. So let's start here with a point Q. So that will be our -6 minus our 6. And that is going to give us our vertical change. When we move over to the horizontal change, I'm going to start with point Q again. So that is going to be a 1 minus, so that's the 1, and we are subtracting a -3. Right? So what is -6 minus 6? That is a -12. -6 minus 6 is a -12. And this is being divided by 1 minus a -3. So 1 minus -3 is a +4. Now, if you look at this line, how are we expecting our answer to be? Are we expecting a positive gradient or a negative gradient? If you are thinking of a negative gradient, then you are absolutely correct. And why is it negative? Because when we are looking at our graph, as we are increasing in x values, the y values are going down, which means this is a decreasing linear graph. And a decreasing linear graph gives us a negative gradient. So let's go back to our calculation and see. We have a -12 divided by a +4. Well, firstly, a negative number divided by a positive number will give us a negative answer. And if we look at 12 divided by 4, that is a 3. So our gradient here is a -3, as expected from this decreasing linear graph. Now, how do we find the equation? We now need the y-intercept. So let's find that using our standard form, mx plus c. So we know that we are going to substitute we are going to substitute y, we're going to substitute the gradient, which we have as our -3, and we're also going to substitute the x value. all of this so that we can find our y-intercept. So which point are we going to take? Remember, as long as the point is on that line, then you can use it. So in this case, we can take a point P, remembering that this is our x value and this is our y value. So -3 for the x and a +6 for the y. So let's substitute. The y value is a +6 and the x value is a -3. And when we are now calculating there, a -3 multiplied by a -3 is a +9. And on this side we have the 6. Then we are going to be using the additive inverse of 9 so that we can find our c. So that is going to be a 6 minus 9. And 6 minus 9 is a -3. And that is our y-intercept. And if you look at our line there, we can see that it is passing where y is equals to -3. So we could have easily also taken that off of our graph. So what is our equation there? Our equation is y is equals to -3 for our gradient and a -3 for our y-intercept. And that is the equation of that line. Let's quickly go to an ad break and then we'll see you just now.